In this part, we will discuss about mole conversions. So first thing you need to know what is mole. For that, please check part number 1 where we have discussed about mole in detail. Mole is just a number. To start with conversions, the first thing which we need to know is what is molar mass. So molar mass is the mass of one mole of substance which is equals to its relative atomic or molecular mass in grams. So when we talk about the molar mass, that means we are talking about the mass of 1 mole of particles. So it may be 1 mole of atoms, it may be 1 mole of molecules, it may be 1 mole of ions, it may be 1 mole of cations, it may be 1 mole of anions. Okay, when we talk about 1 mole, that means we are talking about 6.022 into 10 raised to the power 23 particles. So you can say, for example, mass of 1 mole of oxygen atoms, or you can say mass of 6.022 into 10 raised to the power 23 atoms of oxygen is 16 grams. You represent molar mass in gram per mole. The next thing is atomic mass. What is atomic mass? Atomic mass is mass of one atom. It is the mass of one atom of an element in atomic mass units. And for example, mass of one atom of oxygen, that is 16U. Mass of one atom of carbon, 12U. Mass of one atom of hydrogen, that is 1U. So molar mass is mass of 6.022 into 10 raised to the power 23 particles, and atomic mass is mass of just one atom. To get the mass of 1 mole of atoms of an element, that is molar mass, we must take the same numerical value. That means this numerical value will be same. Okay, you have to take the same numerical value, but you have to change the units from U to G. For example, let's take oxygen atoms. We know that mass of one oxygen atom is 16U, and mass of 1 mole of oxygen atom, that means mass of 6.022 into 10 raised to the power 23 oxygen atom is 16 gram. So numerical value, this 16 is same. The only thing which changed is unit. That means from U to G. Let's take another example. O2. O is atom, O2 is molecule. Okay, so mass of one oxygen molecule is 32U. But mass of 1 mole of oxygen atom, that means mass of 6.022 into 10 raised to the power 23 oxygen molecule is 32 grams. Numerical value is same, only difference is for one atom you will use atomic mass unit, and for 1 mole you will use grams. Let's try to understand that with one more example. 1U hydrogen has only 1 atom of hydrogen, whereas 1 gram of hydrogen has 1 mole of atom, that is 6.022 into 10 raised to the power 23 atoms of hydrogen. Similarly, oxygen, 16U oxygen has only 1 atom of oxygen, but 16G atom has 1 mole of oxygen atoms. So 1 mole means, mole is just a number, the value is Avogadro's number. Let's move to the next point. In the first part, we have discussed that mole act as a bridge between mass and number. If you know the mass of anything, you can tell the number of particles in it. If you know the number of particles, by using mole as a bridge, you can tell the mass of anything. So before we go actually do the mole conversions, let's try to understand by using one analogy of dozen. Okay, so in this, the given is 1 dozen is equals to 12. The value of dozen is 12. Okay, so we are taking examples of eggs. So we can say that in 1 dozen we have 12 eggs. And I am just assuming that the weight of 1 dozen egg is 24 grams. Okay, these are few assumptions which I am making here. Okay, so now let's see how dozen act as a bridge between mass and number. If I ask you a simple question, tell me, if you have 1 dozen egg, how many eggs do you have? What you will do in that case? If you have 1 dozen eggs, how many eggs do you have? So your answer will be, sir, we have 12 eggs. But how basically we reach to this point? If you have 1 dozen egg, you are saying that you have 12 eggs. So that means you are multiplying 1 with the value of dozen. The value of dozen is 12. If you have 2 dozen egg, you will say, sir, this is 2 into 12. 2 into 12 is equals to 24. If you have 3 dozen eggs, 3 into 12, 36. So next question is, if you have 36 eggs, can you tell me how many dozens do you have? If you have 36 eggs, how many dozens do you have? In that case, in your mind, you will do some calculation and you will tell me the right answer. But exactly what you are doing is you will divide 36 with 12. 12 is again value of dozen. You will divide 36 by 12. You will say, sir, we have 3 dozens in 36 eggs. So that means right now we are dealing with a number. When I say how many eggs do you have in 1 dozen, you multiply that with the value of dozen. When I say how many dozens do you have in given number of eggs, so what you are doing is you are dividing. That means when you are moving from here to here, you are multiplying with the value of dozen. When you are moving from here to here, you are dividing with the value of dozen. So now in the next part, we'll talk about the mass. So in the given here is 1 dozen of eggs weighs 24 grams. Okay, so my first question is, if you have 1 dozen eggs, can you tell me how many grams of eggs do you have? So what you will do in your mind, you will say, sir, that is 24. That is given in the question. So but what actually you are doing is you are multiplying 24 with the value of dozen. 1 dozen eggs weighs 24 grams and 2 dozen will weigh how much? 2 dozen will weigh 2 into 24, that is 48 grams. Okay, so that means when you are moving from dozens to grams, what you are doing is you are multiplying with the value of dozens. So now the value of 1 dozen egg is 24 grams. The next question is, if you have 48 grams, if your eggs weighs 48 grams, can you tell me how many dozens of eggs do you have? So in that case, what you will do is you will directly say, sir, we have 2 dozens. So but what you are doing on the paper, you are dividing 48 with 24. So that means when you move from grams to back to dozens, you're dividing with the value of 1 dozen of eggs. How much 1 dozen of egg weighs. When you're moving from dozen to grams, you're multiplying with that value, and when you're moving from grams to dozens, you are dividing with that value. So now just tell me, instead of eggs, if I say what is the weight of 1 dozen of pineapples? So the first question you will ask, sir, tell us what is the weight of 1 dozen. Okay, give us the value. Okay, because the weight of egg will be different as compared to pineapples, and the weight of pineapples will different as compared to apples, and the weight of apples will differ as compared to bananas. So as we change the fruits here, as we change from one substance to another, the weight of this dozen, the weight of 1 dozen will change. So now let's use this analogy in moles. The way dozen act as a bridge between the number of particles and mass, mole also act as a bridge between number of particles and mass of particles. And how we will do that, we'll try to understand with the help of this discussion. Okay, so first thing is, what is molar mass and how to calculate? So let's try to understand how to calculate the molar mass. So say for example, I want to calculate the molar mass of H2O. Okay, so first thing is, let's calculate the molecular mass of H2O first. That is 2 into 1 plus 16. It will give you 18U. That is the mass of one molecule of H2O. So if you want to calculate the mass of 6.022 into 10 raised to the power 23 molecules of H2O, that is if you want to calculate the molar mass, you have to keep the numerical value same as it is. Just change the unit from U to G. Let's try to understand how to convert mole to particles and moles to grams. Okay, so since it is acting as a bridge, first let's try to understand how to convert moles into particles. When I say particles, that means I am talking about atoms, I am talking about molecules, I am talking about cations, I am talking about anions. So if you know number of moles, say for example, you know that you have 5 moles of anything, you have 5 mole atoms, you have 5 mole molecules, okay, you have 5 mole of anything. So how to convert that into number? The only thing you need to do is you have to multiply the value of mole. Okay, the value of mole here is, say for example 5. Multiply the value of mole with the Avogadro's number. The way the value of dozen is 12. If you want to calculate how many eggs are there and 2 dozens, you are multiplying 2 with the value of dozen, that is 12. So here the value of mole is Avogadro's number. And how many moles are present? 5 moles. So multiply 5 with the Avogadro's number. In 1 mole, how you will do that? 1 into Na. That will be 6.022 into 10 to the power 23. In 10 moles of anything, that means 10 into Na. That means when you moving from moles to particles, you are multiplying with the Avogadro's number. So now if any question comes, tell me how many moles are present in 1 atom of oxygen, okay, or 1 atom of anything. So how you will do that? Just divide the given number of particles with the value of mole. That is Avogadro's constant. That means if you want to move from number of particles back to moles, just divide that with Avogadro's constant. Next is basically if you are moving from moles to particles, you are multiplying with Avogadro's number. If you are moving from particles to back to moles, you are dividing with Avogadro's number. Okay, so now let's move to the another side of the bridge, where basically we have to convert moles to grams. So how we will do that? So we have discussed the example of H2O here. Say for example, you have to calculate the weight in grams of 5 moles of water molecules. How you will do that? Just multiply 5 with the value of 1 mole of water molecules. 1 mole of water molecules means molar mass of water molecule. The molar mass of water molecule here is 18. Okay, so you will get the value 90 grams. So that means in 5 moles we have 90 grams of water. So whatever value is provided to you, whatever number of moles are given in the question, so what you will do is, if you have to convert number of moles to grams, just multiply number of moles with the molar mass. If in question, say for example, they are saying that the given mass of anything is, say for example, given mass of water is 36. Calculate the number of moles present in 36 gram of water. So what you will do is just divide that with the molar mass of water. Which thing we have to divide? We have to divide the given mass with the molar mass of water. So given mass here is 36. Molar mass of water is what? Molar mass of water is 18 grams. That is what we have calculated. So 36 divided by 18 is 2. So that means in 36 gram we have 2 moles of water. So if you want to calculate the weight in grams from number of moles, just multiply that number of moles with molar mass. In case the weight is provided, in case the weight is given, just divide that weight with molar mass, you will get the number of moles. In case you have to calculate the number of particles present in 18 gram of water, so what you will do is first calculate the number of moles. Okay, so you have 1 mole present in 18 grams. Then what you will do is you will multiply the value of 1 mole, that means 1 into Na. That will be the number of molecules of H2O present in 18 gram of H2O. Let's move to the next part. Now we will try to apply all these concepts in some questions. So in the first, they want us to calculate the mass of the following. The first is mass of 0.5 mole of N2 gas. 0.5 mole of N2 gas. And you have to calculate the mass. So let's see, we are on which side of the bridge. So we have to calculate the weight in grams from what? From moles. That means we have to move from here to here. So given number of mole is 0.5 of N2 gas. Okay, you have to calculate the M, because now you have to multiply with 0.5 into M. What is M? M is the molar mass. So how you will calculate molar mass of N2? So that is 2 into 14. Okay, that is equals to 28 grams. So this is 0.5 into 28. So it is equals to 14 grams. So in 0.5 mole of N2 we have 14 grams present. Okay, we have 14 grams of nitrogen gas. N2 is molecule. If in the question they are saying, next question they are saying N. N means atoms. So that means what we have to do now is they are saying 0.5 mole of N atoms. So first we have to calculate the molar mass of N atoms. So how you will do that? So that is 1 into 14. So the molar mass of N is equals to 14 grams. Okay, so this is 14 grams. So what you have to do is, next thing is 0.5 into 14, 0.5 into 14. So the answer is 7 grams. Okay, so next question is, They are saying, they are giving you the number of particles. So now we know the number of particles. What we have to do is we have to calculate the mass. We know the number of particles and we have to calculate the mass. That means first we need to go from here to here, and then we have to go from here to here. Okay, so first calculate the number of moles. So number of moles is, say for example, the given particle is N. So N is equals to 3.011 into 10 raised to the power 23. And we have to divide that with Avogadro's number, 6.023 into 10 raised to the power 23. And then in the next step, what you need to do is, okay, now this will give you the number of moles. You can represent that with small n. So from moles, if you have to go to grams, what you have to do is you have to multiply that with molar mass. So what is the molar mass of n atoms? We have just calculated that. That is 14 grams into 14. So this is 1 by 2 into 14. So the answer is 7 grams. Let's try to solve the next question. The next question says 6.022 into 10 raised to the power 23 number of N2 molecules. So the given here is number of particles. If you want to convert number of particles to moles, so what you have to do is divide that with Avogadro's number. Let's divide 6.022 into 10 raised to the power 23, that is given in the question, with Avogadro's number, that is again the same. So what it will give? It will give us the number of moles. So now we know the number of moles. Next thing is we have to multiply that with molar mass to get the weight in grams, to get the mass. What you will do is, they want us to calculate the molar mass of N2 molecules. That means there are 2 atoms of nitrogen. That is 2 into 14. So it will be 28 grams. So multiply that with the molar mass. The molar mass is 28 grams. If you didn't cut it, it will be 1. So it will be equals to 1 into 28. So your answer is 28 grams. This is how you can solve different types of questions. So the next question says, calculate the number of particles present in 46 gram of sodium atoms. Given weight in the question is 46 grams. Okay, that means what we have to do is, we know the weight in grams, and you have to move from here, and then you have to move from here to here. So the given weight here is 46 grams, and we know that the molar mass of sodium is 23 grams. Okay, that is given in the question, 23 grams. So what you have to do is, the given weight is 46. So number of moles N is equals to, given weight is 46 divided by molar mass. Okay, molar mass is 23. And then what we have to do is, once you know the number of moles, then in order to calculate the number of particles present in it, you have to multiply that with Avogadro's number. So this will be 23 2s of 46 into Na. Okay, and you can say the value will be 12.044 into 10 raised to the power 23 particles are present in sodium. If you want to know the molar mass of other particles, okay, if molar mass is not provided in the question, just open the periodic table. In the periodic table, you can check the molar mass here. Okay, so let's summarize what we have learned till now. The first thing which we have learned is, if you know the number of moles and you want to determine the number of particles present in that. When I say particles, that means if you want to determine number of molecules, number of atoms, number of cations, number of anions present in any moles of substance. So what you need to do is, you need to multiply that with Avogadro's number. So if I represent mole with small n, so what you will do is, you will multiply small n with Avogadro's number. N is the number of moles. So the first formula which we have learned is, if you want to determine the number of particles, number of molecules, number of atoms, let's denote that with n. So n is equals to small n, small is the number of moles, into Avogadro's number. So that is your first formula. The second formula is, if you know this number, if in the question they have provided you the number of particles, they have provided you the number of molecules or number of atoms or number of ions, so what you need to do is, so in that case you will divide that with Avogadro's number. Okay, if you are moving from here to here, you will multiply. If you are moving from here to here, you will divide. So what will be your formula? formula is, now you need to determine the number of moles. So number of moles N is equals to capital N, that means the number of particles which is known to you, divided by, that is Avogadro's number. Next thing is, if you know number of moles and you have to determine their mass, so what will be the formula? So the formula is basically you have to multiply number of moles with molar mass. So let's say the mass which you have to calculate is represented by small m. Small m is equals to the number of moles which is known to you, N into capital M is your molar mass. So I will write that in the bracket, molar mass. Okay. So the next formula is, this is the formula number 3. If you're moving from here to here, you will multiply with number of moles. Next formula is, if in question they have provided you the given mass, say for example 36 gram. So we will represent that with small n m again. So, and you have to determine the number of moles. So what will be the fourth formula? N, number of moles, is equals to given mass over molar mass. Okay. So in this case, what you will do is you will divide that with molar mass. So how you will remember all these 4 formulas? If you want to deal with number, that means if you have to calculate the number of molecules, number of atoms, number of ions from moles, and you know the number of moles, so what you will do is you will multiply that with Avogadro's number. If you know the number and you want to determine the number of moles, divide that with Avogadro's number. Okay. If you want to determine the mass of given number of moles, multiply that with molar mass. If you know the mass and you want to determine the number of moles, divide that with molar mass. So these are the 4 formulas which you have to apply in order to solve any numerical problems related to moles. So thank you everyone. In the next part, I will discuss different numerical problems related to mole concept in detail. So please check the next part for detailed numerical problems.